Hey, what's up, guys? Welcome back to PTS Care Expert and myself, Architect Kumar Kapadia from the city of Surat in Gujarat. And today's exercise is going to be all about creating this interesting facade. How can you create such interesting elevation treatment using phase-based family, wherein you see that this is just a single family, single module, panel-based family, which has been computed and multiplied and hosted across this facade. For example, if I just select this and press say that CS creates mirror, you see that you can host it to any of the wall, right? Any of the face. Any of the face you can host it. And once hosted, what you can do is that you have two instance parameters. One is the parallel material and another is the pivot rotation. And second rotation is driven by the pivot rotation. For example, if I just change this to, let's say, 10, then you see it changes the angle, and likewise you can have the variation across this particular one single family, and it is a phase-based family. Okay, so if I just take it to this particular one family, and if I just go to edit family, then you see that this is the template file where that particular family has been designed and it has been created and hosted in left elevation. Fine, computing it with this particular computational formula and parameters. But this is one single family that is panel module, and which has been treated several couple of ways by embedding and nesting into various different template families of Rabbit, wherein again if I just select the panel module and go to edit type, then you see that this is that particular family, single panel. Fine, and this also has been treated by assigning various formulas, computational formulas and algorithms. Okay, again this particular family, single panel, is a generic family which has been designed here. So you see that a lot of nested and embedded families, one within the another. So it is going to be a very interesting and insightful session. So just watch the entire video till the end. Fine. And if you think that this particular video was worth, then kindly enroll for this particular course, Master Diploma in Revit BIM, which is a combo of architecture plus structure plus MP, of which next live session is going to start from next Thursday, that is 6th of June, 6:30 p.m. sharp. Fine. So now for today's topic, let's start with this particular exercise. Fine. And what I'm going to do is that I'm just going to new and create a simple family first, because there are a lot of nested and embedded families which are going to be taken into consideration. Going to family templates, English Imperial, and not English Imperial. We are going to use metric system for this particular exercise, because you see that this panels, the computation of this panel required round figure, okay, which is not possible in feet inches. So family and English, and I will just use this particular metric generic model. Fine. Okay, and UN, while going to UN project units, I will just turn this particular length 2 meters, rounding up to 2 decimal places. Okay, and just click that. Okay, fine. So now first is that we are going to design the single panel. First step is to design the single panel. Okay, so what I'm going to do, I'm just going to use this extrusion, and with this work plane to be reference level, I'm just going to use this inscribe polygon, okay, with four sides, and I'm just going to create one like this. And you see that this instance dimension, this temporary dimension, sorry, not instance dimension, temporary dimension, I'm just going to click all of them and turn them into the permanent dimension. Fine. Let me just reduce down the view scale. Now this two dimensions I'm going to turn into the parameter L1. Fine. That would define the length 1. Okay, and that would just be a type parameter. That's okay. And this 2, I'm going to say that L2, another length. Okay, and that is also going to be the data type, the length. And let's group it in a dimension. Fine, it's a type parameter. Okay, now I'll just go to this particular family types, and herein I will say that L1, this particular thing, L1 should be 0.25 meter, because I want this complete length to be 0.5. Okay. And this L2 is going to be the thickness. So that is going to be really a small sliver. So let's say that 0.005 for 50 mm, apply, and okay, fine. With this, you see that this particular small sliver has been created, and I guess that this should be actually 0.005. So, okay, so that would make it 50 mm, 2 inch. Okay, so 0.50 meters by 50 mm, that is 0.005. Okay, and I'm just going to say that the extrusion end should equals also a parameter. And what would be that? That would be panel height. Okay, PH for short, or let's name it perfectly, panel height. Okay, and that would also be a height parameter. Okay, because anyways we are going to nest it and embed it into different files wherein we are going to pass on this particular height parameters. Okay, so just click that OK, panel height, and OK, fine. Now I will just hit the checkbox and let's go to 3D. Fine. So you see, what do you see? This is just a small sliver and small panel, fine, of 0.5 meter. Its length, but height is still 0.25. So let it be 0.5 by 0.5. So I will just change this to 0.5. Okay, and apply, and okay, fine. So now this is just a square panel, okay, of 0.5 length by 0.5 height. I will also assign it a material parameter, wherein I'm just going to turn this button and associate that into a parameter, calling it panel material. And that is going to be, for right now, it is going to be a type parameter. Okay, type parameter. Okay, now we are going to host this particular family into another family. The reason being, right now this family will only have two reference planes. These are the 2D reference planes across which we have hosted this particular element. So now if we embed this particular element into another generic model, that will only have two reference planes. But for the purpose of creating this stuff, we essentially need to create panel which would have reference planes on all the four sides. Right? So you'll understand it slowly and gradually. So I will just go to File and New and create one more family. And this would be matrix generic model again. Okay, that will open up four views by default, and I will just close all of them. Okay, fine. And now I will pass this particular single panel into that particular file, embed that into that. But before doing so, I will just go to the family categories and type, and from always vertical, I'm just going to change it to work plane base. What does that mean? That means that always vertical families are families which are hosted to the another. When you pass on that particular element to another file, they are just placed like the way they are designed in the host file. In the host file. So, and the work plane based families are the families which you can host to any surface. Those are face based families, or any elevation or any view. Fine. So this particular family which we are going to design is supposed to be a work plane based family. Okay. So that's why I'm just going to convert this into a work plane based family, and after converting this, I will load that into this family too. Okay. And once loaded, you see that now it gives an option whether place on face or place on work plane. So right now I will say that place on work plane, and I will just place it somewhere over here. Okay. And I will just get rid of this particular family because it is hosted in that family and we don't need it. So I will just expand this family section and go to this particular generic model. Fine. And rename this, calling it single panel. Okay, just copy it and rename this as well and paste it. Okay, so now this particular family is embedded in this particular file. Now, as I said, this is the work plane based family which needs to have the reference plane across all the four sides. Okay, so 1, 2 and 2 more reference planes we need to define. How are we going to do that? Okay. So first is that I will just go to create, create and reference line, not reference plane, but reference line. Okay. And I'm just going to create a circle of radius equals. I first need to go to UN and convert this to meters and rounding up to 2 decimal places. Okay, fine. And with that, I would say that circle, and I would define a circle of 0.5 meter. Okay. Now we are going to host this particular element in this quadrant. Okay. But before that, again, I will click reference line and create one perpendicular. Exactly 45 at 45 degrees. You see that this dotted line pops up showing that this particular reference line is exactly perpendicular. Okay. Now I'm going to create 2 tangents which is intersecting this particular circle. So one, I will just drag it, and one. This will be more clear once I load this particular. I complete the modeling process of this particular file and load that into another. I will just make you explain that what is the purpose of doing this particular thing. Okay. Now, what I'm going to do, I'm just going to strike a parameter and constrain this newly defined reference plane. Reference planes or reference line? Yeah, reference lines. Sorry, not reference plane. These are the reference planes. These are the reference lines. Okay, which carries integrated work planes associated to it, onto which you can host a geometry which would have a rotation. So this is going to be a parameter where I will call this vertical tangent. Okay, and this is going to be an instance. Fine. And this is going to be horizontal tangent. That will also be going to be an instance parameter. Okay. Fine. Now, what I'm going to do next is that I'm just going to go to this particular family type. But before that, I would just like to go to any of the elevation. Let's go to front elevation. And I would define a reference plane, a 2D reference plane. Select that. You see that this temporary dimension pops up. I'll just convert it into a permanent one and make this a parameter calling panel height. Okay. That would also be instance. Fine. With this parameter defined, now I would like to go to family types. Okay. And what am I supposed to do? Yeah. First is that I need to host this particular family onto this, across this reference planes and this reference lines. Okay. So I will select this and say that move, enter. I will hover my mouse until it reads endpoint. What's this point? Endpoint of the generic model single panel. So I will just select that center and I will host it not to the center of reference line, but it should read, press tab, and it should read endpoint of reference line. It should be the endpoint of this reference line. Okay. With that, I will just say that RO, rotate, place the center of rotation, select this point and, from this point, see right now, RO, rotate, and this is the center of rotation. I will say that place, and I will again snap to the endpoint of reference line. Watch this point. It should read endpoint of reference line. Click, select this and just rotate it 0.45. Okay. I will hide this particular reference line for now. And from here, I will just drop down this, creating an angular dimension, of which if I just hover my mouse, you see that this panel has an associated work plane. Didn't I tell you while designing this particular element in its host file, cross this particular 4 reference plane, 2 reference plane, we design this particular element. So as soon as now, whenever you try, you can snap to those reference plane across which it is modeled. Okay, so I will select this reference plane and this and strike angle parameter. Okay, this particular parameter also I am going to convert into a parameter which I'm going to call it panel angle. Okay. And for now, it is going to be a type parameter. That's okay. Fine. Okay. Now this particular single panel, okay, of which I'm going to pass on one of the parameter, one of the type parameter, and which would be that would be height. So I will go to front elevation of this, and yes, panel height. This is already, I have made this particular parameter. Yeah, panel height I made. But what I need to do is that I need to make it equals 0.5. Okay, so that will snap to the height of the panel. But before proceeding, I would just like to go to single panel, edit type and type properties, and associate this panel height parameter in this particular file. So that particular parameter has been passed on. Apply and OK. Fine. Now, what I'm going to do next, let's just test out whether this particular angle parameter is working. I'll just turn it to 60. Yes, fine. 70. Okay. 30. Yes, and 45. Testing out of parameters is very important in parametric modeling at each and every stage. Okay. Now, what I'm going to do is that I'm going to constrain this particular element with the help of these two parameters which we have created, horizontal and vertical tangent. Okay. So I'm just going to family types. What I'm going to do is that I'm going to strike certain computational formulas wherein you see that this panel height is 0.5. So what I'm going to do that I'm going to tell Rabbit that horizontal tangent, this distance should be whatever is the height. So you know that the height, the width is 0.5, and the length, the overall length of the panel is 0.5, and height is also 0.5. So horizontal tangent should be 0.5 cross in times sine into parentheses open panel angle, and I'll just press space. So this will constrain this particular element irrespective of its length, height and its rotation. Fine. I will just copy this, and vertical tangent, this is nothing but just the computational logics and the computational formulas. Fine. Back to school days, mathematics. So 0.5 into cos panel angle. Okay, and with this I'll just click say that, apply and OK. Fine. Now I will select this particular single panel, and if you remember, we also had this panel material which also needs to be passed on. So I will again associate this with the family. We passed on this panel height, but this panel material was remaining. So I will associate this button and turn it into a parameter, calling it say panel material. And for now, let it be a type parameter. That's okay. Because once moving it into a phase-based family, we are going to turn all of this into an instance parameter. Fine. Now, this particular family 2 is having this single panel. Okay. Now we are going to host this family into a phase-based family. So what I'm going to do, I'm just going to go to File and New, and this time I'm just going to create that family. And from the list, I'm just going to use this. Instead of metric generic model, we used this particular family file 2 times, metric generic model. Now I'm going to use this metric generic model phase-based, and it's going to be a phase-based family. Okay. So this is a phase-based family. If I just go to 3D, then you have this particular box. Okay. You have the face of the box onto which you can host a geometry. Okay. A reference plane, 2 reference planes, and this particular face. Okay. So what I'm going to do, I'm just going to go to reference level of this family 2 and load that particular into the project. But before that, most important step, again, go to this family category and parameters and turn it into a work plane based family and uncheck this always vertical. I hope that we did the same process for that single panel. Let me just go to edit and go to edit, and yeah, so see, this is a work plane based family. Okay, so that's okay, fine. So this is also going to be the work plane based family and always vertical. Okay, the reason being creating this into a work plane based family, I will just explain you. Okay, so this I will just say that family 2, I'll just load into family 3, that is the face based family, and I'll just click OK. And you see that you have an option, place on face or place on work plane. So what I will do, I will just go to this reference plane and say that pick. And from this, I will select this reference plane. Right? This reference plane, left, right. Because this is going to be considered the face of the wall onto which we are going to put that element. So with left, right, with that selected, if I just click OK, it will ask that which elevation do you want to go. I will say that I want to go to left elevation. Fine. And with that left elevation, I am just going to host this particular file and I'm just going to embed. Okay. And I'm just going to expand this family section, generic models, and rename this, calling it panel module. Copy and rename this as well and paste. Fine. Is that now we are going to constrain this particular family, this panel module, into this particular face-based file. Okay, face-based template file, wherein I'm just going to click a reference plane first. Okay, and turn this into a permanent dimension. Okay, and I will just create one parameter to control its distance from face. This is going to be the face, or this is going to be the face of the any 3D element, whether it is wall or surface or anything onto which you are going to host this element. Okay, so I will just create a parameter to control its distance from face, and that is going to be offset parameter, which I'm just going to turn it to 0.03 for now. Okay, fine. Now what needs to be done is that create certain computational formulas here to control this particular element, wherein I'll just go to family types. You have this offset parameter. I will just create one new parameter calling it pivot rotation. Fine. I'm just going to turn it into an instance and angle. Fine. And that should be group under dimension. That's fine. Okay. So that is an angle parameter of which I'm just going to copy this. Copy, and I'm just going to create one more new parameter. And that would be second rotation. Fine. And that would also be an instance. Okay. And that would also be an angle parameter. Okay. What I'm going to do is that I'm just going to call this second rotation a computational formula, wherein I'm just going to say that 90° minus pivot rotation. Fine. So with that, you have created these two computational formulas, pivot rotation and second rotation. Fine. Apply and OK. So now, after creating this particular computational formulas, now we are going to compute this particular panel module by assigning it various parameters and computing it. Okay. Of which first is that you see that if I select this panel module and if we drop down, you see that it has two instance parameters, panel angle and panel height. Okay, and it has one of this type parameter, of which this panel material I am just going to pass on this particular material parameter, wherein I'm just going to call it panel material, and this time it's going to be an instance, because we are going to have instantly different material for different panels, okay, in the project environment. So I will just pass on this parameter, apply and OK. And now if I just go to family type, then you have your panel material, okay, in this file, in this face-based file, which is an instance material, okay, instance parameter, okay, not material, instance parameter, sorry. So now we need to compute this, of which I'm just going to go to this panel height, and that too I'm just going to pass on, creating one parameter that is going to be panel height, okay, and that is also going to be an instance parameter. Fine. Okay. What I'm going to do is that I'm just going to select this particular thing, this panel module, CS, that is create similar, and I'm just going to press space a couple of times until you find this orientation, which this, and I'm going to snap it to the bottom. The family, the the reference plane of this family 2, the bottom reference plane, okay? And this was the reason. You see that now when you select this particular one family, and if you just press align, you will find a reference plane across all the 4 sides, okay? And that was the reason for nesting and embedding it into a different generic model file in order to have this reference planes of which we can snap to, okay? So with this, now what I'm going to do is that I'm just going to first convert this, call this panel angle, it will equals to pivot rotation, okay? Fine, pivot rotation, and this is 45. Oh, sorry, I'm supposed to change this to 0. Apply and OK. Fine, so this has changed its rotation to 0. And this I will select, okay, of which I'm also going to pass on this panel height to panel height. That's fine, but this panel angle, this angle parameter, I'm going to associate it with this parameter. Which parameter? Second rotation, and just click OK. Fine. With this, now both of this are two different, the same family panel body, but treated two different ways, okay? Of which now I'm just going to go to family types and convert this pivot rotation to 45, okay? And apply and OK. Now is the time to snap. So I will just click this particular align, find this, watch this point, find this particular center, left, right, and lock. Okay, it will pop up this error, but that's fine. Okay. Now we need to constrain it to this bottom reference plane. So again, I will click align, snap, and lock, but escape out. Again, press align, select this reference plane, find this reference plane, and lock. Okay. And finally, select this vertical and select and lock. Okay. So now is the time to test out whether it is perfectly working or not. Fine. So this is the phase-based family that we have created. Okay. So now the time to test out. So what I will do, I'll just go to this particular family categories. From here, I will just change this to 30. So that will automatically change the second rotation to 60. And because of the computational formula that we have assigned in its family file, this is reacting perfect. 40, okay, and 10, okay, and completely, if you want to have this surface, then fine. Or if you want completely 90, then this, okay, but I will say that 45. With this, I'll just say that apply and OK. The reason of this is that now I'll make you explain that if I just go to this particular panel module, then if you just go to reference level, then didn't I tell you that this particular tangent parameters are going to control this computational formulas, sine, panel, angle. This is nothing but just a computational pure mathematics, okay, and that is controlling the rotation angle of that particular family when hosted into another family. Okay, now with this perfectly done, now we are done. What we just need to do is that, let me just check that whether everything has been passed on. Yeah, parallel material has also been passed on. This parameter has also been passed on. Okay, so now what we need to do, I don't need it. So I'll just close this family 2. Okay, so now this particular family 3, I'm just going to load here. But before that, what I will do is that I will just get rid of this particular curtain panel. Let me just get rid of this entire, just delete it, because I'm just going to. So this file already has this panel phase-based family. Now we are going to load this particular family 3 into that particular project. Okay. So what I will do, I'll go to left elevation and load this into the project. And you see that you have an ability to place on work plane or place on face. But with that place on face, we need to define a face. So here I'm just going to create, while going to wall, I'm just going to create one curtain wall, fine, and I'll go to edit type, wherein I have already defined, see, because I want the round figure, I made this particular file in feet, in metric system, okay, and the vertical spacing should be 0.5 meter, okay, and the horizontal spacing should be 1 meter. Why? The reason being, that this particular file, if we just measure this, then if you remember, then this length we have defined 0.5 meter, okay? And when this will completely expand, so 0.5 plus 0.5, so that will become 1 meter. So we need to define a curtain panel with the grid division in such a way that its vertical grid should have the spacing of 0.5 meters, but the horizontal grid should have the spacing of 1 meter, because we are going to host that particular phase-based family onto this particular curtain wall. Okay, so I have just computed it, and I will just draw it real quick and make you understand that. I will just go to this. I don't need this particular file because it's already loaded in the project environment. I'll go to level 1, and herein I'll just delete this particular floor, or let's hide it, delete it. So I was earlier working on this particular file, so that's why it was having that floor plate. Okay, I will go to architecture and wall, and with that curtain wall, I will define, if I want 19 segments of 0.5 meter, then the width of this particular curtain wall should be 9.5 meter. Okay, and with that 9.5 meter, I want the height to be 7 feet. Okay, and since we had divided it into the segments, if I'll just go to south elevation, and I will just hide in view by category. As I said, I was earlier working on this file. See, if I just go to modify, and if I just measure, then this horizontal division, this particular horizontal division will be 0.5 equidistance, and 19 of them, right? 19 of them. The reason I will just explain you why. And this is going to be 1 meter. Okay. Now, what I'm going to do is that I'm just going to load that newly created family 3, and not this. This is the existing which I have already designed, parallel phase base, but this is the newly created. Let me just rename that also, panel phase base, PFB for short. Rename this as well. Right? I'm just going to drag this, and since I said that this is a phase based family, so you see that you have an ability to place on work plane or place on face. I will say that I want to place on face of this particular curtain wall. So I will just place on face, and with that, you see that I can snap to this particular face, and I will just click. Okay. With this, you see that it has two instance parameters. One is this panel material, another is this panel height, and another is this pivot rotation. And this second rotation is driven by this pivot rotation. Okay. So I will just change this pivot rotation to 0. So that will expand this panel CC. Okay. And from this, what I will do is that I will just hide this particular floor for now in elements and view, and go to front, or let's go in south elevation. Or you have this panel. Okay. Move M, enter, select this snap point, endpoint, and snap it. Okay. Just like that. You also need to snap it in plan. So what you need to do, you need to go to top, and you see that this particular distance, which distance is this? This is the offset distance. If I just go to edit family, then you remember that in left elevation, we defined a reference plane at 0.03 meter, giving it an offset. So this is that particular distance it is snapping to. Okay, so if you just measure from here to the center of this, then you see that it will be exactly that 0.03 of this. See, okay, so that is not important. Fine. So I will just select this particular move, and with constraint uncheck and disjoint check, I will just move it from this point to this point. Right. So we have snapped it to this particular CC. Okay. Now what I'm going to do is that I'm going to select that particular newly created panel phase base. Okay, and say that array. Okay, array, and with move to second, I'm just going to move it from here to here. And since I know that this are 19 panels, 19 of them, I'll just enter that figure 19. So that will compute, and now you have 19 panels of them. Okay, with this, I will just select all of them and say that, or let's say SA. So all 19 of them are selected, and I'll just say that ungroup. Okay, with that ungroup, now I will select this. Okay, and again say that array. Where is array? Yes, and select this filter and check none. And yeah, there are a lot of things. So just we need to select the generic models. 19 generic models, apply and OK. And with that, you see that now this array function is active. So array and move it to second. We'll move to second and move it. And this should be 7 of them. Fine. So with that, we have entirely computed this particular panel by placing all the panels. Okay. And with this, I will just say that SA and again ungroup them. Okay. By ungrouping, what I will do is that I will go to 3D of this. Okay. Now is the time to sign it. Since you know that each of this phase-based family has the instance parameters, 2 instance parameters. That is panel. This actually panel height. If this could have been height parameter, then also it doesn't make any difference. So just ignore this parameter. Okay. So what important is just 2 parameters. That is panel material and panel rotation. Okay. And the second rotation, which is driven by this particular pivot rotation. Okay. So what I'm going to do is that I'm just going to south elevation, select this both. Okay, and that would be, I will not change any angle for them, but for this two, what I'm going to say that multiple categories. So I'm just going to select SA and HI. That will temporarily hide, because you see that there are a lot of elements over here. When I select all of this, you see that there are curtain panels, grids, generic models, walls, a lot of things. Okay. So I will just select this SA, that will select all of them, and I will just press HI, that will temporarily isolate it. Okay, and select these 2 panels, these 2 rows. These 2 rows I will select, and you see that you have an ability to instantly change this pivot rotation, of which I will just tell that this should be 8. Okay, not 80, sorry. 10. Okay. Fine. And the material, I would just go to this and let's say that let's have any wooden panel. Yes, on this wooden panel 3. Okay. For this 2. Okay. Fine. So it has changed. Okay. For this 2 rows, I will not change the angle. What I will just change the material. And what material that should be? It should be any of the existing one. Let's change it to this shaft. Right. Okay. Now what I will do, I will just select these 2 rows, wherein I will just change this pivot angle to 70. Okay. And not 70, sorry, 30. Okay. And this is SAS. So just copy, select those 2 rows and change this material, panel material. Since it is an instance material, you can change instantly. Instance parameters are the parameters for any 3D element which you can change instantly. Now I will just select these 2 rows, change this material to wooden panel 3. Okay, fine, and change this angle to, which was the last one, the 10, 20, and this should be 30. Okay, no, this is 30. So this is supposed to be 40. Is that this is 0, this is 10, so this should be 20. Yeah, sorry. So this should be 20. Okay, and this should be, select this for 2 rows, and this should be 30. Okay, and likewise now this rows should be 40. First, let's give the rotation 40, and this should be 50. These 2 rows should be 60, and this 1 and 2 should be 7, right? Large. This 2 will be 80, Okay, and this finally, this should be 85. Okay, now just quickly select all of them and have an alternate material design. Sash, yes. Select this. Let me just select this and copy this. Control C. One, I two. Sign that. Okay, and this should be 1, 2. That should be sash. This 1, 2. This should be that wooden panel. Okay, this also to be that wooden panel. Okay, and this. Oh, sorry. 1, 2, and this should be sash. Okay, and finally the last row, this should be paste, the wooden panels 3. Okay, with that, if I just go to 3D, then you see that we have created that particular beautiful elevation treatment for that facade. Okay, and if I just say that R enter, then you can visualize this particular thing. Okay, here. So with this was that particular tutorial. Fine. I'll just say that no, we'll again open up that same file. So we'll be able to see the end product. Fine, perfect end product. Okay, so just watch this particular entire video till the end. And if you think that this was worth, then kindly enroll for this course, Master Diploma in Revit BIM, which is the combo of architecture plus structure plus MEP. Okay, of which I am the tutor of architecture segment. Right, so kindly enroll for this course and let's learn together and let's grow together. Right.